In this video, we're going to go over practice questions on set theory, more practice questions different from the ones that you've made so far on our channel. You are going to focus on this kind of notation. Okay, so if you're trying to look for a video that is basically talking about the laws on sets, or maybe a video that is trying to show you how to shade, a video that is trying to show you how to simplify to the simplest form, or maybe set interval notation, just kindly check out our other videos on set theory. So we do have a playlist for set theory. You'll be able to find those videos. Okay, so let's start. List the elements in the following set. So I'll start with set A. So x is such that x is even, x is less than 18, x is also a member of what? Natural numbers. So basically the key thing that we need to understand is what does it mean when they say even. So even means that you're talking about numbers that are divisible by 2 without giving a remainder. So examples are 4, 6, 8. Those are examples of what? Those are examples of even numbers. So now, not only are we interested in even numbers, we are also interested in even numbers that are what? That are less than what? That are less than 18. Okay. And again, the even numbers that we are interested in should also be what? Should also be natural numbers. So in short, to combine all what we have, we are saying set A is made up of even numbers, and these even numbers are less than what? Are less than 18, and they're part of natural numbers. So we understand that natural numbers basically gets to start from what? Gets to start from a 1 going up. Those are our natural numbers. But basically when you just say generally, when you talk about even numbers, a set of even numbers is going to start from as low as a 0. So you have 0, you have a 2, you have a 4, you have a 6, 8, 10, 12, 14, 16. So we're saying less than 18. 17, which is less than 18, is not an even number, so we would end at 16, generally speaking. But in this case, we are saying whatever we're going to list should be what? Should be a natural number. So now if you ask yourself a question, is 0 a natural number? No, it's not. So unless they said a set of what? Whole numbers. So basically set A just becomes 2, 4, 6, 8, 10, 12, 14, and 16. So we've listed our set A there. We can move. So how about the second part? Second part is telling us to say our B is basically from -2. So we are saying B is equal to x is such that -2 is less than or equal to x, then x is also what? Is also less than or equal to 7/2. Then x is also a member of what? X is a member of integers. So now, if you ask yourself a question, what do you get to say? What are integers? You need to understand what integers are. That's when things are going to make sense to you. So when you're talking about, so whenever you see this letter, it represents integers. So now, what are integers? So integers basically are going to be negative and positive whole numbers. So it's like you have 1, 2, 3, 4, 5, 6. So not only do you have that, but you also have 0, -1, and -2. So what you need to understand is when you're talking about integers, integers doesn't include fractions. It only includes all numbers. Okay, that's the way it is. So that is a set of integers. So now we're trying to list integers that are between -2 and 7/2. So what are we going to have? So when you say -2 is less than or equal to x, it implies that that is also part of a set. If we had just said -2 is less than x, -2 would have not been part of a set, but we are just we're including it as well because of the equal sign of a dash that is below the less than sign. So it's less than or equal to. So when listing our set B, we're going to start from -2. So we're saying they're going to be moving in the order of just integers. So -2, -1, 0, 1, 2. So if you look at 7/2, 7/2, if you get to divide, it's basically 3.5. Okay, so now 3.5 is not what? 3.5 is not an integer. Okay, so even when it is saying is less than or equal to 7/2 and x is a member of integers, 7/2 is not going to be part of the set. So we're going to have a 3. So 3.5, which is 7/2, is not going to be part of the set because we are only interested in what? In integers. Okay, so that is the way you get to approach such a question. Make sure that whatever you are listing there should satisfy all the conditions given. Okay, part C. So x is such that 4 plus x is equal to 3. Okay, then x should also be a member of what? Should be a member of natural numbers. So we are like, okay, so what we're trying to say is like whatever value of x that you're going to have, when added to 4, it should give us a 3. And this value, so this is likely to be a set made up of one member or one element. So so 4 plus x, if you can even equate that, so 4 plus x basically is equivalent to 3. So x is basically going to be 3 minus what? 3 minus 4. Okay, so basically your x is going to be what? Your x is going to be a -1. So x is equal to -1. Now if you ask yourself a question, is x equal to -1 or is -1 a natural number? No, natural number starts from 1 going up. So do we have any value of x that is a natural number that we can add to a 4 to give us a 3? Is it possible? Of course not. So we can therefore say that there is no value of x that can satisfy the two conditions that are given there. No two values can satisfy the conditions given. There is no value of x when added to 4 giving us a 3 that is going to be a natural number. Unless if I said integers, because -1 qualifies to be an integer, it qualifies to be a rational number, it qualifies to be a real number. So if you are confused about the sets of numbers, check out the tutorial that is appearing there on top. Okay, let's try to move D. So set D, x is such that x is a multiple of what? The multiple of 3. Then x is also less than 10. So a multiple basically is the opposite of a factor. So when you say you're talking about a multiple of 3, you're trying to talk about numbers that are divisible by 3. And these numbers should be less than 10. So what numbers are less than 3? Or what numbers, sorry, are less than 10 and are divisible by 3? So we can think of 3 itself. So 3 itself is divisible by 3. Then 6, what else? 9. So these are the 3 numbers that are multiples of 3 and are less than what? And are less than 10. Okay, so that's it about D. We can move to the last one, which is F. So for the last one, what are they saying? X is such that x squared is equal to 4. So I can write that. X is such that x squared is equal to 4. Then x should be a member of integers. So what can we have in such a case? So let's try to find the two values of x that can define a given equation. So x squared is equal to 4. So what two values can satisfy? So it's either x is going to be plus or minus root of what? 4. So we have positive 2 and negative 2. So when these two are plugged in that equation, they're able to satisfy the equation. Now, not only should they satisfy the equation, they should also satisfy the other condition, which is that the values should be what? The values of x should be integers. So is positive 2 an integer? It is. Is negative 2 an integer? It is. So we have two members in this set. So set F is going to consist of negative 2 and a 2, because these are the only two numbers that are able to satisfy the two given conditions in the builder notation. Okay. So that's it for the first part of the question. If we move to B, B is saying let the universal set U be made up of. So in this we're trying to use the same language that we are using from the previous question. So let's try to see. So feel free to pause the video and try out the listing there, the sets that are given in this case. So list out that one and this one. So I'm hoping you've done that and you've listed them down, just as we get to confirm them now. So our U is basically, which is our universal set. X is such that, so this one will go direct by listing the elements. Okay. So X is such that X should be less than 10 and X should be a member of natural numbers. So natural numbers are counting numbers from 1, 2, 3, just going up. Now we are saying we are interested in the ones that are less than 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is not included, but if we had x is less than or equal to 10, 10 would have been included. Now when we say x is less than 10, we're just interested in the numbers less than 10. So that is our universal set. So we can clearly see what our A is. It is listed. We can also see what our B is. It is listed. We cannot see C, so we need to list our C there. So x is such that x is equal to, so given that our x should be equal to 2k plus 1, so that is what is going to give us the members, then this k should be a natural number. Okay. So, and remember what is limiting us in this case is the universal set. So whatever values that we can have should be what? Should be within the universal set, meaning that they should only be numbers between 1 and 9 in whatever set that we have in this case. So our values of, or members of C are going to be given as 2k plus 1, and k should be a natural number. So I can start by coming up with a first x value, which is going to be a natural. So natural numbers are starting from 1 going up. So the first one that I can get as my value of k is 1. So if I put a 1 there, 2 times 1 is a 2 plus a 1, of the 3 as our first member. Then I can also get a 2, plug in a 2 there. 2 by 2 is going to be a 4, plus 1 is going to be a 5. I can also get a 3, a plug in there. A 3 by 2 is going to be a 6, plus 1 is going to be a 7. I'll get the next natural number, which is a 4. So I'm just looking at the conditions that we've been given. So if I get a 4 by 2, this part is going to be 8 plus 1 is going to be a 9. If I get a 5, it's going to be 10 plus 1, 11. So are we going to write 11? No. Why? It is not part of the universal set. So we just get to end at that point. So these conditions are very easy to understand. Just hope that you've gotten the points and how to go about it. So we've already listed U. We've already listed D. So we've even listed C, which was not even asked. Anyway, it's okay. Then E. So E is saying that x is such that x is equal to, so x should be equal to 2k. Then k should be a member of natural numbers. So in this case, we'll start by plugging a 1. So we're trying to look at the natural numbers. So if we get a 1, it will be 1 times 2 is 2. We get a 2, 2 times 2 is 4. We get a 3, 6. It's just like being doubled. Whatever value of k you get is doubled. You get a 4 is going to be 8. You get a 5 is going to be a 10. So is 10 going to be part of a set? No, it's not part of a universal set. So the universal set basically consists of all the elements that are part of what? That are part of a discussion. So whatever the subset is supposed to have is supposed to be contained first of all in the universal set. So it's very important that as you come up with a universal set, you come up with the right elements, because if you miss it there, you're going to mess up everywhere. Okay, so we've listed the required sets. We've listed the required sets. So it was U, D, and E. So I'm sure there's supposed to be a correction there. So basically set C, the one that we've indicated to be set C, is basically supposed to be a D. Okay, I can show that. So this was supposed to be a D. Alright, then so this is our D. Then our set C is basically supposed to consist of these elements. It's just a bit of it was just omitted. So set C instead has got members from 5, 6, 7, 8, and 9. Okay, so that's what we have. So now we need to look at the other questions. So we've listed the subsets U, D, and E. Now what do we need to understand? So the second part of the question is requiring us to find A intersection C union E. So these are the basic ideas that we've talked about already. Okay, these are the basic ideas. So I'll just do, I think I can do the first one, this very one. Then anyway, let's get to do all the questions. So A intersection C union of E. So this is like a question that we have. So the smart way of approaching this question is by first of all trying to list what is in the brackets. So I'll say my set A is being intersected by what? So our set C, or our set A, sorry, is being intersected with C union E. So A being intersected with C union E. So when you say C union E, basically what elements are you trying to look at? You're trying to combine the elements in C and E together. So you need to list them. So let's try to combine them with what we're going to have. So we're going to start from 2, 4, with 5, with 6, 7, 8, 9. So if you look at the listed elements there, are they part of C and E? So 2 is, 4 is, 6 is, 8 is, 5 is, 6 is, 7, 8, and 9. So we've listed all the elements. So that is what it means when you say union. You need to combine all the elements. So now we're trying to find the intersection between set A and what we have. So look at what we have in the brackets there. Compare it with against A. A is consisting of members from 1 all the way up to 5. So all the way up to 5. So these are the common elements that are also in A. So basically when you come up with your solution, basically it's just going to consist of what? That. That's how easily you can answer these questions. Okay, so we've answered the first part of the question. Okay, what else do we need to answer? We also need to look at B minus A. So when they say B minus A, they're trying to say whatever element that you have in B, subtract the ones in A. So I can write my B. My B is consisting of what? So if you look at our B, it's 4, 5, 6, 7. It's 4, 5, 6, and 7. Remove B. Our B is consisting of what? Oh, you remove A, sorry. A is 1 up to 5. So it's like you get to list all the elements that are, you need to subtract whatever is in A from B. Okay, so what is in A and is in B? So we have 4 is common and 5 is common. So these are the ones that we're going to remove from A. So basically B minus A is just going to be 6 and 7. So that's the basic idea. You need to remove whatever is in A from B, so that you just remain with the B only, with B without A. In other terms, B minus A is B without what? Without A. So we've answered that one. Then we need to find the A intersection B minus B. A intersection B minus B is going to be equal to, so I'll start first of all by looking at what is in the brackets. So in the brackets we have A intersection B. I'll write it there. So what are the common elements between A and B? So our A is from 1 to 5, our B is from 4 to 7. What are the common elements there? So I can clearly see that we do have 4 and 5 as the common members. So then we are saying A intersection B is only 4 and 5. Then this is subtracted by B. Our B is consisting of 4, 5, 6 and what? And 7. So what do we have? So if you remove 4 and 5, if you remove 4 and 5 from A intersection B, what are you going to remain with? You're not going to have any elements. Okay? You're not going to have any elements. It's going to be an empty set. That's the idea here. Okay? In other terms, if you want to understand this better, you can also expand it. You know, when you say minus, so you have A intersection B, then you're saying intersection B complement. That is another interpretation of the subtraction sign there. So it's like you're trying to find, remember, when you say A intersection B, these elements are going to be part of B as well. So there is no way an element can be part of B and then also be outside B, because B complement means the region outside B. So you can't have an intersection of a set and its complement, and that's basically explains why our solution is an empty set. Okay. Then the last one says F minus what? Minus A intersection D in brackets, complement of it. So before we get to move, we need to find what's in the brackets first of all. So in the brackets we've been given A intersection D. So I'll start with A intersection D. So A intersection D means the elements that are in A and D. So our D is consisting of 3, 5, 7, 9. Then we need to find the intersection with A. A is from 1 to 5. So 3 and 5 are the common elements. Then when you say the complement of it, it means that you're interested in the elements outside the intersection of A and D, but within the inverse set. So knowing that our inverse set is consisting of elements all the way up from 1 all the way up to 9, so we need just to remove 3 and 5. So remove 3 and 5 from the inverse set. Then whatever is going to remain there is going to be what? So we can even change it to be the A intersection D complement, because our A intersection D is only 3 and 5, so the complement of it would mean all the other elements remaining in the intersection set. So now we need to remove all these elements from F. So our F is consisting of what? So our F is consisting 1, 5 and 9. So we need to remove all the ones that are listed there. So we need to remove 1. So I'll remove it. We need to remove 2. 2 is not there. We need to remove 4. 4 is not there. We need to remove 6. Not there. 7 not there. 8 not there. 9. I'll remove it. So the only remaining elements after removing the A intersection D complement is going to be a 5. And that is our solution to the last part of the question. Okay. We do have another question. Very interesting questions. So it is also based on the same idea. So I would want you to first of all to just get to first of all gets to list the ones that are presented in the set builder notation, the universal set, and set A. So before we get to illustrate the information on a Venn diagram, let's first of all try to look at the idea of listing. So our universal set is going to consist of, so x is such that x is a member of natural numbers, then from 1 all the way up to 21, because 1 is less than or equal to x and x is less than or equal to 21. So that means that 1 and 21 can be the members if they are also natural numbers. So what are natural numbers? We said natural numbers are the numbers that you get to start counting from what? From 1 going up. So all those are natural numbers. So from 1 all the way up to 21. So basically our universal is just going to be 1, 2, 3, 4, 5, 6 all the way up to 21, because all these are natural numbers in between, in that order. Set A, on the other hand, is basically, so I can even remove the universal set because it's not very hard to remember. It's just from 1 to 21 because they are all natural numbers. Then A is equal to x is such that x, so x should be equal to 2k plus 1, then x should be less than 20, and k is a member of what? Natural numbers. So what does this mean? So the values of x that we're interested in should be less than 20. They are the ones that are going to make up A, and these should satisfy this. Okay, so we can start by inputting the natural numbers. So I'll start with 1. 1 times 2 is going to be a 2 plus 1 a 3. Again, I put in a 2. 2 times 2, 4 plus 5. Again, I put in a 3, 6, 7. So we've seen that it's basically a trend of a difference of what? A difference of a 2. So likely, if we put a different number there, which is a 4, we're going to have a 9. Put in a 5, we're going to have what? We're going to have an 11. We're going to have a 13. We're going to have a 15, a 17, a 19, and what else? So less than 20. X should be less than 20. So 19 is the last value that we can have, because in that trend we expect to have a 21, but 21 is not basically going to be part of the set. Okay, so we are there. So we've listed set A. So our idea now is to illustrate this information. Let's try to illustrate it in the diagram. So we have set A, B, C. Okay, so we have A, we have B, then we also have what? We have C. So I'm hoping all these elements are going to be shown. So it's what we're going to do is we need to list them. So A, so this one has got more elements, A, right? So we can put A, that one can be our C, and that one can be our B. So try to look at the common elements. Which elements are in all the sets A, B, and C? We write them. Elements that are common in A, B, and C. So I can start comparing. First of all, I can start with a 1. If I check 1 in C, is it part of A? No. It is part of B? Yes. So 1 is what? 1 is part of only B and C, and not part of what? And not in A. So it's only going to be intersecting. So I'll put a dot. So a dot indicates that it's a member. We only don't put dots when you're only putting a single number representing the numbers of things. For example, you say 10 people were taking both biology and chemistry. You just get to put the number 10. But where you have got elements, you need to put a dot there. So 1 dot. Then if I continue in my C again, if I check my 2 there, my 2 is not part of B. Is it part of A? It's not. So 2 is only in C. I'll write it in C. I go to my 6. Is 6 part of B? No. Is it part of A? No. It is only in C. I go to my 8. Is 8 part of B? Yes. Is it part of A? No. So it's in the intersection of B and C. I go to my 9. Is my 9 part of B? No. Is it part of A? Yes, it's there. So I'll write there. So 9 is intersecting between A and C. So there. I go to my 11 there. Is 11 part of B? No. But we can clearly say that it's part of what? It's part of A. How about 15? 15 is also part. It's part of A and not part of what? B. So it's just intersection there. So we are done with C. We can go to our B. Our B. I'll check our 3. Is 3 part of C? No. Is it part of our A? Yes. So it's A intersection what? A intersection B. 8 has already been taken. 8 was already part of both B and C, so you can just remove it there. 19 is not in C, but it's part of A, so it's intersecting B and A. Then 20 is only in B. Okay. What else are we remaining with? So 20 is gone. So 19 is already taken there. 13 is not taken. So I can go to my A and also look at it. So we can clearly see that 5 is only in A, right? It's not in B, it's not in C. 7 is only in A, it's not in B and C. 13 is only in A, it is not in B, it is not in C. 17 is only in A, not in B, and not in C. So I'm hoping what I've done is right there. I'm just hoping that I've not made a mistake. So if there's any omission, you can correct that. Just give us a comment that you've omitted one of the elements in that. But I'm sure this is very effective, especially if I'm using different colors to counter check each set one by one. So we need to make sure that all the elements in the universal set are listed. Okay, so remember in the corner there you need to show that this is your universal set. Okay, so our universal set is consisting of natural numbers from 1 all the way up to what? All the way up to 21. Okay, so 1 to 21. So is 1 part of what we've listed? Yes. So do we have, so we didn't have any elements that were intersecting between all that were common between A, B and C. We don't have. So 1 is already part, 2 is already part, 3 is 4. I can't see 4 anywhere. You can write it there outside. 5, can you see 5 anywhere? Yes, it's in A. 6 in C. 7 in A. 8, it's there. 9 is there. 10 is not there. You can put it outside. 11 is there. 12 is not there. 13 is there. 14 is not there. 14 is not there. You can put it outside. 15 is. 16, can you see 16 anywhere? No. 17, yes. 18, no. 19, yes. 20, yes. 21, Can you say 21 anywhere? No. So you need to make sure that if you count all these, they're supposed to add up to what? They're supposed to add up to 21. So I'll start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So all the elements have been listed and been presented in what? In our Venn diagram there. So now, let's try to answer the questions that have been given to us. How do we get to answer the questions that have been given to us? So we've said using the Venn diagram. So this requires you to understand the regions that are under discussion. Okay, so let's try to do that. Let me just move this a bit, just once in one direction. Let's move it in one direction, just one side. Okay. Okay, much better. Alright, so let's try to do that. So we have our AB and our C on our Venn diagram there. So said question 1 says A complement intersection B complement. So that is De Morgan's law. So what does that mean? It's also equivalent to what? It's A union B complement. So you're trying to talk about the region outside the union of B. A union B complement. So you combine the entire region of A with B. Now outside of it is what is going to be our members. So in this case, if you get to combine your A and B together, unionized, it's this region. So we're shading the entire region of what? The entire region of A and what? A and B. So all the elements that are in A and B are not going to be listed. We're only going to list outside that because we are interested in the complement of the two. So our first part, the solutions are going to be, so we have 2, 6 that are only in C and everything else outside. So if I include what is outside, from 2 we'll move to the 4 there. So we have 2, 4, we have 6, then from there we have what? I think we have a 10, we have 12, we have 14, we have 16, we have 18, we have 21. So these are the elements that we have for the first part of the question. Okay. Moving to the second part. The second part is telling us A union B intersection C. So you look at the elements that are in A union B and are also in C. So when you talk about A union B, you're trying to combine the entire region of B with what? The entire region of B combined with the entire region of what? The entire region of A. Now, those elements should also be part of C. So it's like what I've covered there, whatever I've shaded there, the red lines are trying to show the entire region that is part of what? A and B. So now, intersection C. So including the part of C, which is this one. So the common elements there is basically what we're interested in. So we can clearly see that we have a 1, we have a 8, 9, 11, and what? And 15. So this is how you get to use the Venn diagram to show your work or to simplify sets. It's very easy actually. So then moving on to the third one, it is A remove B union C. So B union C means that combining the entire region of what? The entire region of B with C. So if you combine B with C, it's like what you're going to have is this region or this region combined together. Yeah, you've combined the entire region of B and C. So now this combined region is supposed to be removed from A. So remove it from A. What is going to remain in A is your solution. So in A we're only going to remain with 5, 7, 13, and 17. All the other elements that are part of B and C are removed. That's the interpretation there. Then finally, A union B complement. We understand that basically that is equivalent to this under De Morgan's laws. So you just like get to combine, A union B you combine A with B together, now outside of it. So whatever the solution that we found in the first place is basically what is going to be a solution to the same question. Okay, we are trying to look now under the subsets. What is a subset? We need to understand what a subset is. So a subset is a set that is part of another set. Okay, so basically when you're trying to find the number of subsets, the general formula that we get to look at is 2 to the power n, meaning that if you have a set with one element, your number of subsets is supposed to be 2. If you have 2 elements, the number of subsets is supposed to be 4. If you have 3 elements, the number of subsets is supposed to be 8. Okay, so now let's try to see how we get to list them. So just for the sake of understanding, in the case where they ask you proper subsets, for a proper subset, the formula is 2n minus 1. This is the formula for what? For a proper subset. Okay, because the proper subset, this is a case where all the elements of a given set are part of another set. Okay, so now what do we get to have? So for A, we'll have a single element there. So from our general formula, we need to expect what? Just 2 subsets. So an empty set is always going to be part of the subsets. So we're going to have an empty set and also a set containing A. These are the 2 possible what? Subsets that can come out from A. So we have 2. For the second part, we have 2 elements here, A and B. So the general formula is 4. So we'll list it. So for our B, it is we have A and B. So the subsets are going to be the set itself, apart from the set itself, we also have an empty set. Then we can now try to, the subset is any set having elements that are contained in another set. So we can also have a set that is just made up of A. It is a subset of that set because A is in B. We can also have another set just having a B. Yeah, so these are the possible subsets, and there are 4. So try out the last one. So I'm hoping you've tried it out. So here you need to have 8 subsets. So remember, we can start with an empty set, the set itself, then we can have a single element in each set. So these are subsets. Then we can also have a combination of A with B. We can also have a combination of A with C, and we can also have a combination of B with C. So these are, let's say, how many are there? So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is the way you come up with a subset. Like, just try to come up with a set containing the given elements. Okay, of course, even with different combinations. Okay, so the general formula guides you and will help you understand if you're done or not. Okay, so for this video, this is where we end. I just hope that you've understood some of the basic and very important concepts under set theory. So if you still have some challenges, let us know in the comment section, and send us questions via our email, transcendedinstitute@gmail.com. We'll be able to get back to you within 48 hours. Thank you very much, and have a good day.